Hey guys, how's it going? Jacob here. In today's episode, I'm going to give a description about the second level engineering class provided by Project Lead the Way, Principles of Engineering. So without further ado, let's go ahead and get started. Okay, so let's start off by reviewing what the course catalog says for the 2018-2019 description of Principles of Engineering. Now, bear with me because this is kind of a long one, so I may stutter a little bit. The course catalog reads, "This course focuses on the process of applying engineering, technological, scientific, and mathematical principles in the design, production, and operation of products, structures, and systems. It is designed to provide students interested in engineering careers to explore experiences related to specialized fields such as civil, mechanical, and materials engineering. Students will engage in research, development, planning, design, production, and project management to simulate a career in engineering. The topics of ethics and the impacts of engineering decisions are also addressed. Classroom activities are organized to allow students to work in teams and use modern technological processes, computers, CAD software, and production systems in developing and presenting solutions to engineering problems. Students will also be introduced to the fundamentals of robotics and how this equipment is used in an automated manufacturing environment. Students will evaluate their design solutions using various techniques of analysis and make appropriate modifications before producing their prototypes." So basically what the gist of all that means is that Principles of Engineering gets a lot more hands-on than Introduction to Engineering Design. Students get to actually make products rather than just design products and hardly make any physical adjustments. You actually get to do a lot more with construction. You get to design a product, but you get to put it together, and it's not just something that's putting a few things together. It's actually taking various parts and materials at a very raw state, and you get to put them together to make a final product like engineers should. And you actually get to use proper tools rather than just using stuff like tape and super glue. You'll actually get to do things with drills and various saws, because there are projects where you have to make working products. It's not just a prototype. It has to be able to function, and you can go ahead and test it and see its application. Principles of Engineering also allows students to work a lot more with robotics, because right now that's a very growing field for engineering, because it's a lot easier to have robots do jobs instead of having humans, but you still have to have people make the robots. So Principles of Engineering allows students to have a basic level understanding of programming. Typically, students will get to use Vex Robotics, and a good accompaniment to that is using Robot C, where you get to learn how to program different kinds of robots, and they can perform different kinds of functions. In a later video, I will try to give tutorials about Robot C and basic levels of programming, because luckily a couple years down the road, I actually think I know a little bit more about programming, so luckily I feel kind of smart. That's always a nice feeling. Now, in Principles of Engineering, you're definitely not going to use CAD nearly as much as you did in Introduction to Engineering Design, but it's something where you can't just forget everything you learn, because for some projects, you get to actually 3D print some parts, and you're going to need CAD to be able to design them. Now, you're not going to use it all the time. I guess it really kind of depends on the project and if your teacher is willing to let you do it, but I would say that definitely, if you're going to the school that I go to, that there is a pretty good chance that in POE, you're going to get to try to print some parts for your project. Another component of Principles of Engineering is learning about the elements of power. There are the three main types of power: hydraulics, pneumatics, and electric. Hydraulics is using fluids to be able to provide force for a product. Pneumatics is the similar concept, but instead of fluid, it relies on air. So it's less messy, but hydraulics has more power behind it. The third one is electric, which is pretty different, and it's kind of hard to go into great detail about electric power, but that involves things like voltage, current, resistance, all that stuff that teachers are going to tell you about. I can probably go into later detail, but please don't hate me if I don't. Another topic is going to be kinematics, which has a lot to do with motion. So you're going to learn about projectile objects and trajectory, range, angles, all that stuff, because that's whenever you actually have a product and it goes into motion, because a lot of products aren't going to be stationary, so you need to know how a product's going to move, and if you are going to make it moving the right direction, or if it's going to just overshoot what it needs to do. So you're going to be pretty busy in Principles of Engineering, because yet another topic has to do with the strength and durability of materials, because whenever you're working with materials, you need to know if it's the right kind of material. You can't just pick aluminum for a product and it turns out it's not strong enough and you actually needed steel. You need to be able to tell if it has the right stress and strain, because materials are going to be put under plenty of pressure, and if it's weak enough, then the product will just fall apart and then it's going to be useless. So you're going to learn about how to calculate different concepts such as stress and strain, modulus elasticity. I hope I'm not using these terms wrong. I didn't really look it up, so I'm a bad student. I failed Principles of Engineering. I didn't fail Principles of Engineering, I just lied. One project you're going to get to do in Principles of Engineering is making a hydraulic lift. Now, I don't know if where I go to school they still do some of these projects, because the teacher I had isn't there anymore. So you're going to have different projects, or some projects are going to be done differently. So a lot of this is going to be based off of my experience. When we made a hydraulic lift, we had one set of new hydraulic pumps. Sorry, I got my terms mixed up there. And we had to use some VEX materials to be able to lift a certain weight, a certain height, and whoever got the highest height would get the best grade. I think that's how it went. I don't really remember. We could have gotten extra credit. I just know that the higher you went, the better. And you have to be able to calculate how high it's going to go based on how much water you're going to have, because you're only limited to a certain amount of water based on how much it can hold. Another project that you're going to do, well, possibly going to do, is a ping pong ball launcher, which is going to fall right into the category of kinematics. You're going to have pretty free range of progress with this one, because it's just whatever materials you get. You can go buy whatever materials you may need, and you have to be able to launch a ping pong ball a certain distance. And for this project, I know that it was actually a requirement that we had to have a 3D printed part, because I know that my group didn't get our part printed in time, so we got counted off a few points for that, which was kind of annoying because the 3D printer shut down, so it didn't get printed in time, but it's fine. It's fine. I'm not one to hold a grudge. But right now, as you can see, this is a picture of the ping pong ball launcher that my group made. The concept of it seemed pretty sound, but I would say our issue is that we had inaccurate cutting, so it was really rugged. There was a lot of interference, so it was not a very smooth launch. And now what you can see is a picture of what we were going to 3D print as a part. It was going to be a little container for our ping pong ball to be placed in. That way it could travel up the tube more smoothly and it wouldn't get caught, because the pipe there is supposed to be pulled back. Our part was going to be attached to it, so then the ping pong ball would be able to just be shot right out instead of being all wibbly wobbly. I think it was a good idea. I just think that we didn't really go for a very clean product. But you know what? Do better than me. Make sure that you take the time to design it well, and make sure that you build it well. When you start working with robotics, one of the first projects you're going to be doing is building square bots. Here you can see is a picture of a bot that one of my groups in Principles of Engineering had to make. It was technically for a different project, but I'll explain that in a moment. Basically, it's a bot that is made out of X materials and has basic components on it, such as the motors, the cortex, and the wheels. And you have to be able to program it to adapt to certain surroundings. At first, you're going to program it based on time, so it's going to drive for a certain amount of time, and then you can have it perform a certain task. And then you can have certain things on there like a bump switch or a limit switch, where once that is pressed, then you can have it perform a certain action. Also, you can have a light sensor, where once it picks up a certain amount of light, then it's going to perform a certain action. Or you can have an ultrasonic rangefinder, where once it says it's a certain distance from an object, then it will perform a certain action. And if you're really lucky, you may even get to try to program it with a controller, where you're providing input through joysticks to actually have it move around. I know that when we did it, we had to get it through a certain maze based on the certain different requirements. And I think that was a very good introduction, because we later did projects that involved more specific tasks, and this was a good segue into those later projects. One of the biggest projects that you will do in Principles of Engineering, and the reason I'm saying that is because I know it's one of the biggest projects I had to do in Principles of Engineering, was a marble sorting project. Now, when I took Principles of Engineering, we had an option of either making a vehicle or a sorter, but now I believe that you only get to do the sorter, which you still get to understand a lot of the fundamentals. And that picture I showed before was of the vehicle that my group chose to do, because at the time, one of the options was you could have a vehicle that would pick up these little plastic trash cans that would have marbles in them, and it would load it into your robot, and there was a path that you had to follow, and the trash cans would be placed at different locations. And a big part of that was that you had to use a line follower, because that's what was on the mat. There was one white line that was simulating a road, and it had to go around various turns, and you had to be able to adjust properly. Sorry about that. And our group, what we did was we had a 3D printed part on the side of our robot, where if we were slightly off from the trash can, then it would then feed the trash can into our claw. Once the trash can hit the limit switch, it would close and then go through a process of dumping it, and then it would shake it one more time in case there were any marbles that were still stuck in there. Put it down, raise the claw back up, and then it would move on to the next one. Now, when it comes to the actual marble sorter, though, I don't remember that as well because my group didn't do it, but the basic idea is there are marbles of different colors, and you have to be able to put them through a sorter where, by whatever means you choose, say a light sensor, which I would say is the popular option, or if it feeds it into different paths, you have to be able to sort the marbles accordingly. And I know that I have a couple friends in Principles of Engineering who are using a special type of camera, and I think that's really creative how they're using ideas that are beyond what's conventional. They're thinking outside the box because they have this outside knowledge, and that's what's really good about this project, is that it allows you to be creative. It's very loose with plenty of the constraints. It really just comes down to what you have to do rather than what you can't do. So I think this is a really good project because it definitely involves a great deal of both mechanical and electrical and programming work for this project to be completed. So I know I enjoyed this project. I'm sure you'll enjoy this project too. So I'm sure that there were other projects that I had to do that involved different types of research or just smaller presentations or products that we had to make, and I don't really remember them as well. I'm sure that when the time comes, your teacher will do a great job of explaining what the project has to be. Hopefully, I've provided enough information to get you interested in Principles of Engineering. I know that was a really, really great class. It was a fun time in that class. It was really laid back for me, and we managed to get our work done really well. I'm sure that you'll enjoy it just as much as I did, because I know that I just managed to convince you to take this class. Don't lie to yourself. I know I just convinced you. So thanks for tuning into the video. Make sure to like, comment, subscribe, or share the video so other people can see it, because I know that you want other people to take this class with you. So make sure to tune in for my next video. Thanks for watching. Bye.